Hello, MoNaCo here. Seventh video, bonding unit. We're, talk, we're talking about Lewis dots for ionic compounds this time around. We've done all our naming and our formulas to names, names to formulas, back and forth, either way. We know our Latin prefixes now. We know what a subscript means. We're going to start to draw Lewis dot diagrams. So we know the formula, but we want to know the structure of what it is that we're writing on paper here. So you're going to be able to understand the process for how we draw these Lewis dot diagrams for formulas in ionic compounds. Covalent comes next, but we're going to do ionic first. And so you're going to understand how to show a chemical bond, essentially, in the Lewis dot diagram, starting with ionic. Okay. So why bother? Read in. Are there special rules for drawing Lewis dots for ionic compounds? Absolutely. They somewhat follow the same rules for Lewis diagrams for elements, except now that we're combining atoms, we have to show how the electrons are transferred or shared. And Lewis dot diagrams are going to help us do that. In our examples here on this page, you can kind of see how this corner down here, we have a Lewis dot diagram for a compound. Good old-fashioned table salt. And so we're going to be making pictures that kind of look like that when we're all done today. Okay. There's a process. It starts with giving us a picture of the compound. That's what we want to see, is a picture of our compound. You can't see atoms, so we can only see them figuratively on paper, and this is a way to do it. It shows us that the arranging of the atoms in the compound, which is actually important. The arrangement of atoms determines some of the physical and chemical properties of compounds. So it's important to know how the atoms kind of go together. With ionic compounds, there's always going to be transfer of electrons. Remember, that's what distinguishes an ionic from a covalent. Ionics transfer electrons. Covalents, they share them. So there's a process for ionic bonding that we have to show with the Lewis process, Lewis dot diagrams. And ionics are, remember, always a metal plus a nonmetal, or a metal plus a nonmetallic polyatomic ion, or a polyatomic ion plus a nonmetallic element. There's those four options, but typically it's always a metal plus a nonmetal. So here's the steps. I'm going to have to draw these on the board as we go. The first thing we got to do is we got to draw all the elements of the given compound and their individual Lewis dot diagrams. For this example, we've got NaCl. So what you do is you start out with the elements as they are. And sodium, checking the periodic table here, has one valence electron. I know this because I'm a chemist. If you don't know that, you can look at the periodic table and you find in the electron configuration the last number in the sequence. So for sodium, there's 1. Now chlorine, same thing, but we're looking at chlorine's electron configuration. This one's got 7 electrons around it. Okay. So the second thing we do, we draw the electrons going from the metal to the nonmetal. Your goal is to match up all the unpaired electrons because we're matching up unpaired electrons to make bonds, essentially. So what you do is you draw this sodium with its electron there, and the chlorine with its 7 electrons here, and you show the metal losing its electron to the nonmetal, like that. Okay? That's showing the transfer of the electron. Circling it and arrowing over means that it's transferring, it's going away, it's moving along. Now the last part is we have to show the ions as they're locked into place. Now when sodium lost its electron, it's losing an electron, it became more positive. So sodium now no longer has any electrons around it, so we put brackets around them to show that it's going to be an ion. It loses 1 electron, so its charge would be +1. Now, chlorine, color code this for you so that it's literal. I'm going to put the black dot in there to show that that was sodium's electron that chlorine now has. We put red brackets around chlorine. Now chlorine gained an electron, so it's more negative now, so its electronegativity, well, I'm sorry, its ionic charge is a -1. And you can see the +1 and the -1, if they were to combine, +1 plus -1, makes a total of 0 for a neutral compound. That's a good thing for no overall charge. So for every sodium ion, you have to have a chlorine ion. It's kind of how it goes. Some examples, some more things. Practice doesn't make perfect, it makes permanent. And you don't practice till you get it right. You practice till you can't get it wrong. So let's do example 1 and 3. Example 1 is just like sodium chloride. In example 3, you can see that there's going to be a little bit of a twist here. So the first thing we do is we draw the elements by themselves with their original Lewis dot structure. Potassium has 1 valence electron, and fluoride has 7 valence electrons. 2 at the top, 1 around the bus, until we're full up. Then you circle the electron from the metal that's transferring to the nonmetal, and you kind of pair it up so that there's a buddy system. Now what I want you to do is I want you to draw a chemical reaction arrow here, because that's kind of like the equals sign in chemistry. But then we write these again over as their new ions. K gets brackets and a +1 because it lost 1 electron. And fluorine gets 7 dots that are red, 1 dot that's green because that's the electron that came from potassium. Put brackets around that guy, I'll get a -1. See how it works? Now we're going to go down to number 3 here. Get myself a little more space, put a little more neatly. Aluminum, periodic table says that it has 3 valence electrons. Okay. And we're going to combine that with bromine, but there's 3 bromines. Each bromine has 7 valence electrons. So I'm going to do a Br up here, a Br right here, and a Br right there. Each one has 7 valence electrons. And we're going to show the aluminum, the metal, losing 1 electron to each one of those bromines. Because as you can see here, now that makes a full octet around bromine. And this makes aluminum, have a full octet underneath. So aluminum now, because it lost 3 electrons, it has an ionic charge of +3. Now bromine, there's 3 of them. So we're going to have to draw them 3 times. 3 brackets, Br, 2, 4, 6, 7, 8 electrons around it now. But each bromine, having only gained 1 electron, is a -1 ion. But there's 3 of them. So you draw it 3 times. It's time consuming, but if you do it nice and neat, there's a really good sense of satisfaction. So in this case, you see that the +3 and the 3 -1s, that's a -3 total. +3 plus -3 equals a total of 0. We have a neutral compound. That is a good thing. So at this point, you should have a basic understanding of how to draw Lewis dot diagrams for ionic compounds. Remember, use only the valence electrons from your periodic table. Remember to put your brackets in to show that they're ions after the fact. Put in those ionic charges in the top right corner. Make sure the positive ions balance the negative ions like I was showing. And now you should be able to complete some practice packet problems starting probably on page about 29 or so. So thank you for watching this video and look forward to a lot of practice in class.